Assalamualaikum, my name is Iqbal Shazwan bin Muhammad Nasir. My metric number is CN200-269. I am from Group 2. For question 1, Introduction to Partial Differential Equation. First question is give a brief introduction to partial differential equation. A partial differential equation, or briefly PDE, is a mathematical equation that involves two or more independent variables and unknown function dependent on those variables and partial derivative of the unknown function with respect to the independent variable. So the order of a partial differential equation is the order of the highest derivative involved, a solution or a partial solution. To a partial differential equation is a function that solves the equation, or in other words, turns it into an identity when substituted into a equation. Okay, for B question, consider the equation. So this is a elliptic equation. Any of class of partial differential equation describing a phenomena that do not change from moment to moment, as when if flow of heat or fluid take place within a medium or with no accumulation. Okay, for third question, give a common example of parabolic, hyperbolic, and elliptic differential equation. So this is the problem. So we need to explain what elliptic, hyperbolic, and parabolic. So a general second order linear partial differential equation written as this one. This is the equation. So then we say partial differential equation as elliptic, hyperbolic, or parabolic, so that the equation given. Okay, these are the equation. So for example, we can write the wave equation, the Laplace equation, and the heat equation. For example, hyperbolic, elliptic, and parabolic. So last question, general form of heat wave, Laplace and Poisson's equation. So the heat equation describes a process of a diffusion heat U that still represent the temperature of your body at time and location. So Poisson equation is about a stationary or equilibrium distribution of temperature. That is, you are looking for a function of x alone that describes a temperature, assuming it is not changing anymore. So then that is the Poisson equation. And then for the wave equation is one of the most important equation in mechanics. It describes not only the movement of string and wire, but also movement of fluid surface. For example, water wave. So, and lastly, Laplace equation is a special case of Poisson's equation in which function f is equal to 0.
Hi, my name is Afshin Anlaki Saundrapandi, matrix number CN210251. So today I'll be sharing about question 2, which I've completed. So question 2 was about numerical solution of heat equation using explicit finite difference method. So I have my presentation here, my laptop. So first question, question A, was write down the formula of explicit finite difference method for solving heat equation. So as you can see in the slide, I've done my part. And moving on to B was problem 1, heat equation. So as you can see, I've done step by step following step 1 as shown in the diagram here. So you can refer to the diagram. And step 2, then moving on to step 3 was finding the boundary condition. And then moving on to step 4, and there's a diagram for step 4 as well, that where I've been calculating everything and I've put everything according to the each dots to the correct boxes, and also done the calculation part. And moving on to the last part was step 5, which says calculate UIJ at level 1 and 2 by using molecule graph. So as you can see in the molecule graph, this is the final one. And for the last part is repeat the steps to find UIJ at level 1 and 2. So as you can see here, level 1, and then moving on to level 2, and below level 2 the final we have a diagram. So yeah, that's all from me. Thank you.
Hello and a very special good day to my fellow friend and doctor, especially for our doctor. Okay, today I going to define the wave equation that we're going to solve using infinity different methods. Okay, here we're going to say I have been picked question number 4, numerical solution for wave equation using infinity different methods. Okay, here in the first step we're going to say the formula of the infinity different method to solving a wave equation. Okay, here we're going to see the evaluate the wave equation into an infinity different methods. Okay, draw the graph of the equation. Okay, number 3 is apply the PDE in the infinity different forms. Okay, here is the formula. Just now from the from above, here is the formula, and then we're going to add it in a central space to interpret the value of the ui j plus 1. Okay, here is the formula, here is the figure number 1. Okay, this is figure level number 2. Yeah. Okay, step 4 we're going to use again PDE to define the level 1. Okay, here is the formula AU XO UI. Okay, the difference is above of the second column is 2k. For the this level 1 there was and a difference on the 2k and gx. Okay, and then after finish define the PDE just now. Okay, by subtraction this equation of UI to the 3 level sandwich hill. Okay, here we see the formula just now. Okay, we added just like above, but that I said just now, that I mentioned just now, it was in a different on the 2 on the 2 above. Okay, here is the figure for the level 1. Yeah. Okay, if definitive velocity is 0, then yeah, this is the solution. Okay, here we're going to solve the equation problem 3 wave equation. Okay, here we can see this is the wave equation. Okay, first of all, we, as I mentioned just now, we define it into an infinity form. Okay, this is the grip, the grip, yeah, the grip level. Okay, this is the grip level. Okay, consider the initial condition. Okay, ux is equal to 0 0.2, 0 0.4, 0 0.6, 0 0.8 and 1. Okay, for the step 3 consider the boundary condition. Okay, this is for t, it was 0 0.5 and 1. Okay, step 4 is writing the PDF in a fitly different forms again that I mentioned just now. Okay, this is h 0.2, 0, the k is 0.02. Okay, here we say we put the 0.202 per 2, okay, above this side, above the left side, and the 0.23 below the right side. Okay, here is the expression of the answer. Okay, we can see this is the okay, and the answer for the level 2 is 0.05a plus 1.9b plus 0.05c minus d. This is the followings of the figure. Okay, this means that the target cells at level 2 plus is this is now. Okay, to find the level target 1 that I mentioned just now, we're going to do an PDE forms for the second time to find the target level 1. Okay, here is the forms. As I mentioned just now, this is the difference between the PDE above and below just now, 2k, 2x. Okay, it's gonna be 0.04 2x, and then we bring this x, the 2 just now, this 2k just now, to the front, and we will divide it with all of this equation, and it's become 0.025a minus 0.95b plus 0.025c and plus 0.0 over in bracket 2x and d. That is for the okay, this is the equation, this is the figure for this level 1. Okay, here is the answer. Okay, here is the grips for the level 1. For the level 1, yes, this is the grips for the level 1. Okay, and then this is the grips for the level 2. Okay, here is the answer. Hopefully this can help you guys in the wave equation. Thank you.
Hello, my name is Jason Gallo William, and my metric number is CN190256. So I will be presenting question number 5, 5b. To make it fast, I will summarize everything. So the problem is given by the equations above. So the method used is finite difference method to approximate the solution of Laplace equation. The boundary is given by the value of x, which is must not be more than 1 or less than 0, and the value of y must not be more than 2 or less than 0. So the first step to solve this problem is to draw the grid. So I will explain later in the next step. And then step number 2 is consider the boundary by inputting the function. So first is we extract all the equations out. So e exponent x plus sine pi x for x0. So we choose 0.2, 0.4, 0.6 and 0.8 because the value of x must not be more than 1 or less than 0. Same goes to the other equation. The value of x must be not more than 0.2, 0.4, 0.6 and 0.8. Well, for y, the value for y must not be more than 2 and must not be less than 0. So the equations are shown below. And this is the grid diagram that I mentioned above just now. So this grid is drawn based on the equations that have been calculated from the values that are selected, such as 0.2, 0.4, 0.6 and 0.8. So each Each value that has an error is calculated based on the equation shown previously. And then step number 4 is write the PDE in finite difference form. So this this formula is the formula for the finite difference for Laplace equation. So it is given that h equals to 0.5, k is equals to 0.5. So it will be summarized into the very last equation. And moving on to the step 5. Step 5 is to draw the molecule graph. So the molecule graph is drawn in figure 2. So this means that targeted cell surrounded by 4 cells which may known or may not known. So apply figure 2 into the grids as I shown previously. So at level 1 there are 4 unknowns, namely u 0.2, 0.2 to 1, u 0.4 to 1, u 0.6 and 1, and u 0.8 and 1 to be obtained. So there will be 4 simultaneous equations. So to get the first equation, the red circle molecule graph below are used in figure 3. So these are the circle diagram on the grid. So we will use this to find the values. And these are the equations derived from the circle diagram in the grids. So for the first equation we get the value, I mean the equation, the summarized equation. Same goes to equation number 2, equation number 3, and equation number 4. And then from equation number 1 to 4, it can be written in matrix form as below. So it is solved by the system of linear equations by Gauss-Seidel iteration method. So we can form the equations as shown below, and then we calculated it in the calculator to get the values of each grid. So it can be seen that it is calculated until 3. So the value of the final value for u 0.21 is equals to 1.246, and u 0.41 equals to 1.530, and u 0.61 equals to 1.869. Last but not least is u equals to 0.8 1 equals to 2.271. So that's all from me. Thank you.